Hello everyone, in this video we're going to be discussing Pemphigus vulgaris and Bullous Pemphigoid. Now in order to understand these two diseases, we first need to understand the histology of the skin. Now imagine that this is the basement membrane. Let me label this with BM. So this is the basement membrane. Above the basement membrane we're going to have the epidermal layer, and below the basement membrane we're going to have the dermis. Now, the epidermal layer is going to be made up of multiple layers, and the cells that are important in the epidermal layer are going to be the keratinocytes. Now, the first layer, right above the basement membrane, is going to be called the basal layer. And in the basal layer, the keratinocytes are going to be attached to the basement membrane through hemidesmosomes. Above the basal layer, we're going to have the spinal layer in yellow. And in this layer, the keratinocytes are going to be attached to one another through desmosomes. And that is very important to know. And finally, above the spinal layer, we're going to have the granular layer. And here I'm drawing the granular layer in blue. Now, in Pemphigus vulgaris, we're going to have IgG antibodies against the desmosomes in the spinal layer. So, as you might recall earlier, the spinal layer is going to have keratinocytes attached to one another through desmosomes. So, let me draw the desmosomes in purple. So, the keratinocytes in the spinal layer are attached to one another through desmosomes. And in Pemphigus vulgaris, we're going to have IgG antibodies against the desmosomes in the spinal layer. So what this does is it is going to separate the keratinocytes. So now the keratinocytes are separated, and this is going to form a blister. Okay, so now that these keratinocytes are separated, we're going to form a blister. Let me draw the blister in red. So we're going to start to form a blister as the keratinocytes are separated from one another. Now, because this blister is going to form within the epidermal layer, it is going to thin the epidermal layer and it is going to weaken it. As a result, the blister that is going to form is going to be weak. So it is going to be easily ruptured. And that is important to know because it is going to be a characteristic that is going to separate Pemphigus vulgaris from Bullous pemphigoid. Now, in Bullous pemphigoid, we're going to have IgG antibodies against the hemidesmosome in the basement membrane. So as you might recall, the keratinocytes in the basal layer is going to be attached to the basement layer through hemidesmosomes. I'm going to be drawing the hemidesmosomes in pink. So because of the destruction of the hemidesmosomes in the basement membrane, we're going to start to separate the basal layer from the basement membrane. So that is going to form a blister again. Now, the blister that we're going to form here is going to be much stronger because it is going to compose all of the epidermal layer. So remember, the blister that we formed in Pemphigus vulgaris was within the epidermal layer. As a result, it thinned and weakened the epidermal layer, whereas the blister that we're forming in Bullous pemphigoid is going to compose all of the epithelial layer. It is not going to weaken it, so that is going to form a stronger blister. So it is going to be strong as a bull. That is what you need to remember. So that is the mnemonic that I like to use. With Bullous pemphigoid, we're going to form a blister that is strong as a bull. Now, another important symptom that you need to be aware of in distinguishing Pemphigus vulgaris versus Bullous pemphigoid is going to be the involvement of the oral mucosa. In Pemphigus vulgaris, we're going to have involvement of the oral mucosa. So as you can see from this picture, there's a lesion in the mouth. Whereas with Bullous pemphigoid, we're going to not have any involvement of the oral mucosa. Now, with Bullous Pemphigoid, we're also going to have linear fluorescence. And the reason why this occurs is because we're going to have antibodies against the basement membrane. Imagine that this line represents the basement membrane, and we're going to have antibodies against the basement membrane that is just going to line up. So that is going to create a linear fluorescence. What other disease has a linear fluorescence? Good-Pasture syndrome is also going to have linear fluorescence. As you might recall, Good-Pasture syndrome is going to involve the lungs and the kidneys. We're going to have antibodies against the basement membrane of the alveoli as well as the basement membrane in the kidneys. That is all the important information that I want you guys to know. If you enjoyed the video, please like the video and subscribe to my channel. Thank you for watching.